Recording's rolling. It is Wednesday, April 2nd. So, you guys know for the past few weeks, we've been doing review. We just finished review yesterday, except, well, I could use a couple extra minutes. So, we're going to finish that Bernoulli question from yesterday. And then, on your guys' desk today, you guys have an FRQ packet. So, there's four questions, pre-response questions for practice exam too. It totals to 40 points. So I think like one's 8, one's 12, and two are 10. I think that's how it breaks down. And so I give you guys time in class today and tomorrow, which is pretty much exactly the amount of time that you have on the exam to do it, 90 minutes, minus this time that we're gonna, of course, finishing that Bernoulli from yesterday. So guys, tomorrow at the end of class, turn that packet into the gray tray. And then we'll do a trade score just like we did for practice exam one. And then like always, you guys get points in the actual grade book just for doing it, turning it in and pouring it. But you'll be able to see objectively what how someone else would score it. And also you'll be scoring someone else's. So you can have the mind of an AP grader. Guys, what else should you do by next week? Yeah, these multiple choice questions. So there's 40 multiple choice questions. That's been open for a while. All right. So let's finish this one from yesterday. So we'll step through this. I gave you guys this pipe system. Now, there was this pipe with a radius of 0.25 meters here. That's like 25 centimeters. Right? And then it led into a smaller pipe with a radius of 0.1 meters, which is 10 centimeters, which let's say 40% as much. Now, you might be given these pipes in terms of their diameters, and if you want in terms of radius, you guys know radius is half the diameter, so be ready to field either version of that. I also gave you a height change, and the question is, what's the pressure? Oh, so here's an initial pressure. You had that too, right? So what's the final pressure? Or if you said what's the change in pressure, you could get that either way. Oh, so this is going to be a two-part puzzle. Because before you can do Bernoulli, first you have to do conservation of flow. Okay, so here, I'm going to cover this up. Okay, somebody tell me, how does conservation of flow go for this situation? There you go. Cross-sectional area times velocity is the same everywhere in the pipe system. Okay, so that works out to like cubic meters per second if you were looking at the units. Okay? So I know the area, the cross-sectional area of the circle is pi r squared. Okay, so we got two different radii going. Okay. The pi cancels, but you definitely have to square that radius. It's something to do with area. The pi just turns it into a circle. So there. Okay. Okay. All right. So if I had the initial velocity of 10 meters per second here, I know it's going 62 something meters per second over here. Okay. Guys, does that have anything to do with this height change yet? No. You guys notice I haven't even touched this height change. So this second velocity has nothing to do with that. It has everything to do with the sizes of the pipes. So now we're going to switch over to Bernoulli, this way for Bernoulli, which looks just like conservation of energy, except it's in pressure units. So here's some internal pressure. We've got a rho GH, 1/2 rho V squared, and same thing on the other side. And so two different pressures. Now I gave you the initial pressure as this many pascals. Do you guys know, guys, how many pascals is one atmosphere that you're sitting in right now? There you go, 101,000. It's about 100,000, 101,000. Okay, so this looks about 1.7 atmospheres if you thought about it that way. Right, so if you push through. There's also, you have to account for it is in motion. So I've got this term 1/2 rho V squared here. Density of water is 1,000 kilograms per meter. Right, on the opposite side, okay, now I'm considering this height change. The fact that it's going up some height, which by itself will reduce the pressure, but also the fact that it speeds up, that further reduces the pressure. So I ran the numbers in my calculator. I got a big old negative number. Guess this? No. Here's the next question. Can water pressure be negative? Yes or no? Yeah, it sure can. It sure can be negative. So what's doing is it's pulling on the sides of the pipe. It's pulling it. Okay. But something interesting happens when you get water pressure too low. And I'll show you guys a stagnant version of this. Because if you put water in a vacuum, what does it do? It boils. It does. It does boil. You guys can see that right here. You guys see this? Watch this water. So vacuum chamber just vacuum out all the air. And where's my boiling water? Oh, okay, there it is. Okay, there. All right, boiling water. All right, so guys, is that water hot or is it room temperature? Room temperature. In fact, it's actually getting colder because the boiling process carries energy out of the system. This is thermodynamic. So AP doesn't ask you about thermodynamics, but there's a whole process there. Okay, so anyway, and the fact that it's taking energy out of the system, ooh, that's a thin layer of what on top right there? Ice. Aha, turns to ice. Right. It never got hot. It boiled and it cooled off. That's what happens. Right. Here's another part of physics you missed that goes hand in hand with that is I got this map, so this phase map. Now, this is specific to water, although other materials have similar looking maps. Here's pressure increases on the left side. Notice it's logarithmic, goes up by factors of 10. And then here's temperature increasing to the right. So it helped frame this a bit. These two bars, here's 0 degrees Celsius and 100 degrees Celsius. And this bar going across is 1 atmosphere. So right now in this room, we're right about where my mouse cursor is. Oh, and then water would be liquid in this room. Okay. But if you change the pressure or the temperature, you can get different phases of water. All right. So there's a little bit of thermo that otherwise you wouldn't have gotten it from this class. All right, let's go back over here. Okay. So you guys have a packet of free response questions. Go ahead and take the rest of today and tomorrow to solve those, and we'll score those on Friday.